Hello, hello. Good afternoon. I can see people are still coming in. That's okay. We can start. So welcome and thank you for joining me here. My session today is about Azure Container Apps and how we say goodbye to Azure Kubernetes Services. Very quickly, who am I? My name is Johnny. I am from Belgium. I work as a software developer, software consultant, mostly focusing on .NET, full stack development, and Azure Cloud, cloud native development. The reason I'm showing you this slide for such a long time now is because all of the things that I will show you today, they're already available on my GitHub. So I have a very specific repository on my GitHub for today. It has the examples. It also has a copy of my PowerPoint slide, so you can already download that. So if you just scan the QR code or you follow the link in the bottom of each slide, you will get all of the information already. So I can just get drunk tonight and I don't have to worry about things. Everything is already up there. If there's any questions, you can ask me after the session. I will also be here for the rest of the evening. And if you have even more questions afterwards, you can contact me, find me on LinkedIn, or send me an email, and we will see how we can solve that. So today, I want to talk to you about Azure Container Apps. Obviously, that was the title of my session. And I'm not really a religious kind of guy, but if there is one religion that I want to follow, it's containers. I'm really a fan of containers. And the reason I'm a fan of containers is because it gives us as developers a lot of flexibility in how we deploy our applications. And of course, the concept of software containers comes from the real-life containers. If you look at this picture, this is basically a ship a couple of hundreds of years ago, and the way we needed to load cargo into the ship was quite difficult because we had all different kinds of cargo. We had boxes, we had chests, we had barrels, we had sacks, all different kinds of cargo. And we need a lot of manual manpower to load this onto the ship. And it wasn't really a perfect match because, of course, barrels and sacks don't match up. They leave a lot of space in between. So it's hard to fill a ship very nicely with all of these different kinds of materials. So in real life, we found a solution for that. And that solution was containers. So we basically put stuff in containers. And then each container has a very specific size. It's a standardized size. And the people that need to work with the cargo, with the containers, they don't need to worry about what is inside of the container, unless it's cocaine, of course. But they just care about, this is a container, this is the size of the container, and I can stack my containers. I can put the containers on a ship, I can put them on a truck, I can put them on a train. It will all work because we have something standardized. And in software development, we want to do the same thing. Basically, we or you as developers, you build your software, you put your software into a container, and the people that need to deploy the software and put it on the cloud or on-premise, it doesn't really matter. They don't really need to know about your software or the dependencies from your software. They only need to know this is the standardized container that you are using, and we are going to deploy that in a standardized way. And you as a developer only need to worry about, this is my software, it needs to work, and these are my dependencies and my configuration, and that also has to work. Deploying shouldn't be an issue. Now, I will show you a lot of examples today, and this is not really me. Normally, I would do like real-life examples, but in this case, unfortunately, I only have these small demos to show you specific concepts from Azure Container Apps. So basically, the container applications that I'm going to write today look a little bit more like this. So it's very simple, not enterprise scale, just a couple of containers. We'll link them together and make something work for distributed applications. Now, what am I going to talk about? Azure and containers. Now in Azure, we have multiple different kinds of services already available that can host our containers, our standardized containers. We have web apps. We've been using web apps already for years. And these web apps, you can just deploy them from Visual Studio if you want. You can deploy them using a pipeline, but you can also deploy them using a container image. Web apps can perfectly fine work with a container image and run that container for us. It's the same with function apps. Again, we can deploy function apps from Visual Studio, we can deploy them from a pipeline, but we can also put our code inside of a container and run that container inside of a function app. Then more specifically targeting targeting to only containers, we have container instances, a very simple service. You have one container, you want to run that container very easily, one replica, let's say, it runs, it is available, you can use it, very simple. And then of course, if I skip container apps for now, we have Azure Kubernetes Service, which is a managed service that basically has Kubernetes ready for us to use. And Kubernetes is the other side of the room. It's like you can do whatever you want. There's so much things you can do, there's so much flexibility, but of course, we need to work with that. We need to make sure that our Kubernetes cluster is up to date. We need to manage all the nodes. We need to manage the virtual machines that lie underneath. So that's a lot of work. And that's why I'm very happy that a couple of years ago, Azure came out with the Azure Container Apps service. Because with Azure Container Apps, you have some of the power of Azure Kubernetes Service, but it's abstracted away from us. So we can focus on delivering our software and not really worry about the infrastructure or not worry about the infrastructure too much. We always need to worry a little bit about infrastructure, but of course, not too much. So today I'm going to spend most of my time on container apps. Now this talk is not a Kubernetes versus container apps. Those two are still perfectly fine side by side, but you don't need Kubernetes for everything. You can sometimes use container apps for your applications that are a little bit more simple. If you really want to do a crazy enterprise distributed application and you need all of the flexibility and all of the little toys to figure out, then you can still use Kubernetes. But if your application is a little less complicated, you can perfectly fine, can go with Azure Container Apps. Now, what is Azure Container Apps? Well, it's a service that allows you to run your distributed applications or microservices. For me, it's the same thing. Distributed application, multiple components that work together, that communicate and make up the whole of your distributed application. In Azure Container Apps, which is not something that exists in Kubernetes, you can even go serverless. You can basically tell Azure Container Apps, I'm going to use the serverless consumption model, which I will show you in just a few minutes, which means that you can scale down to 0, which means that if your application is not used, you can scale down to 0 and you're not using any resources. Only when your application gets first time use, for example, you can spin up one instance or multiple instances and actually really make use of this serverless offering. It is also built on existing open source components, components that we are also using in Kubernetes, for example. There's a couple of logos in the bottom. I didn't yet tell you specifically, but Azure Container Apps is actually built on top of Kubernetes or Azure Kubernetes Service. So it's a service, it's a layer of abstraction on top of Azure Kubernetes Service. And again, we don't need to worry about that. We are using Azure Container Apps and all the managed Kubernetes services underneath are managed for us by the cloud platform Azure. Some other of these open source components are Keda, for example. Keda, which is the Kubernetes event-driven autoscaler. Again, an extension you can use within Azure Kubernetes Service. It's by default, it's available and installed in your Azure Container Apps. So you can use that for your dynamic scaling based on events. Then you can see Dapper, the distributed application runtime. This is also something that, again, you can use in your applications. You can use them within Azure Kubernetes Service, but again, they are pre-installed in your Azure Container Apps service. So you can use them if you want. You don't need to, but it's there, and it's very simple for you to use that. And then finally, we have Envoy for your proxy and your load balancing, which is also pre-installed in that service, again, for you to use to, again, take away a lot of that infrastructure worry from you. So now you can just use that out of the box. Of course, what kind of applications can you build in container apps? I just told you containers are a way to put our software inside of a container, and we can actually put everything inside of a container. So you're very flexible in what you want to run on container apps. Doesn't really need to be .NET or C#, can be whatever platform or whatever programming language you want to use. You put it inside of a container, you can run it in Azure Container Apps. For example, it can be web applications, distributed application, microservices application, background processing applications, all different kinds of fun stuff. Now, if we look at Kubernetes itself, it's quite complicated. In Kubernetes, when you want to configure your Kubernetes cluster, you basically need to specify what your nodes are, and your nodes are virtual machines, so you need to specify the size of your virtual machines. Are all of your nodes the same size? Do you have different size nodes? Which is your worker node? Which is your control node? Stuff like that. Again, this isn't always. You shouldn't always need to worry about that. Sometimes you just want to keep things simple. So in Azure Container Apps, we step away from that, and we go to a much more simple architecture. So in this architecture for Container Apps, we have different layers, and I'm going to explain those layers to you, and then I will show you in the Azure portal. So on the outside layer, we have what is called the Azure Container App environment. And this, you can kind of compare it to a namespace in Azure Kubernetes Service. So this is your environment, and your environment is basically your virtual network. And within this virtual network, you can have one or multiple applications that are able to talk to each other because they live in the same environment, they live in the same virtual network. So within that environment, if you created an environment, you can actually create multiple of these container apps. So you put all of your components from your distributed application or microservice application into different container apps, and you put them all in the same container environment so they can talk to each other. So in the level of container apps, A and B on this slide, you now still have a couple of things you can do. You have something that is called revisions. So when you deploy your application, when you deploy your container image to a container app, you basically create your first revision. And this runs your application within that revision. Now, if you want to deploy a second version of your application, you're basically, or at least Azure Container Apps creates a second revision, and it will basically spin up this revision. So it will spin up the containers, and when the containers are running, it will switch over from your previous revision to your new revision. And to make things a little bit more flexible, you can even have multiple revisions at the same time. Again, I will show you in a couple of minutes, but you can do something like A/B testing. You can have most of your users running on revision 1, which is your current release for your software, and you can have some of your users get redirected to a second revision which contains the newer version, and maybe there's still some bugs in your newer version, and you want to look at the logging and at the telemetry to see if everything's fine. And when you see a couple of bugs, you can switch over again, you can fix your bugs, you can release a new version, and when everything is fine, you can make the complete switch to your new revision, which is very, very cool. And then inside of each revision, we have the replica concept, which we also have in Azure Kubernetes Service. You can basically horizontally scale each of your services the way you want. So if you have a web API, for example, and you have a lot of requests coming in, you can use the KEDA autoscaler based on HTTP requests. You can basically tell it, please scale my application from 0 to 100, for example. So 0 means no traffic, 1 when there's a little bit of traffic, and this scales automatically based on the parallel requests that come in up until the maximum that you specify, for example, 100. So these are the different layers within container apps. So if I go to the Azure portal, and I show you the namespace that I've prepared, I've already deployed some of these container apps. So I'm going to show you the first one, the first example API. So this is just a regular .NET API that is deployed as a single container app within a container app environment. Now, this container app has a couple of properties here. It, of course, has its container, so which container is it running? And inside of that container, you have your environment variables, your volume mounts, and bindings you can add to talk to other Azure services if you want. So I created one small environment variable called version, and this is version alpha. Now, because this is deployed, I also have, in this specific case, this application URL. So this is the URL that gets automatically created for you, and I can go to the status endpoint, which is the only one that exists for this specific example, and it just returns an hello world based on the version, the name, please go away, or not, the name of the container, and the current date and time. So that's a very stupid example here. But you can also look at scale. And in scale, as I told you, you can specify your minimum amount of replicas and your maximum amount of replicas. So this scales from 0 to 10. So if there's no requests coming in for a period of time, it will scale down to 0. This is using the consumption workload, which means I'm using the serverless offering for Azure Container Apps, and I don't have to pay for that. When a request comes in, it will basically wake up one of the replicas, and if more requests come in, or a lot of requests come in, it will scale up dynamically based on the amount of parallel requests. So there's a scale rule in the bottom. So you can add scale rules if you want to customize those specific scaling rules. You can customize, of course, on HTTP requests that come in, but you can also scale on messages that you have on a queue, or basically everything you want, because you can also create plugins to do custom scaling. For example, if you have an actor-based framework like Orleans or Akka, you can basically also scale on number of actors within your system, if that is necessary to you. Then we have the revisions and replicas. So here now I have my deployed container app. I'm in single revision mode, which you can see here, which means that when I deploy a new version of my application, it basically gets spun up, and when it's running, it will switch over from the old revision to the new revision. So I only have one revision active. I will show you multiple revisions in just a moment. So basically, I've created two container apps, the API and the worker. So the API just has the status endpoint, and the worker is a background worker. And the background worker is going to call into the API, and that's actually very easy. They live in the same container app environment, so the same virtual network, so they can find each other. I have an additional environment variable here, status endpoint, which has the fully qualified domain name for my API, Azure Container App. And if I look at the output, the log stream for this container, I can see that it's actually every second calling that status endpoint and returning that message and showing that message in the console. So again, very stupid application, but it shows you that now I have two container apps talking to each other. Very, very simple. The code for this isn't very complicated. This is my API. It only has one status endpoint. This is my worker service, and it's using an HTTP client to get a string from that HTTP endpoint defined by that environment variable. Again, very, very simple. You don't have to specify the fully qualified domain name. So if I go back to containers and environment variables, in this case, this is the fully qualified domain name. You can also just use the name of your container app. So if I go back, if I go to the second example, and the environment variables here, you can also do HTTP and then just the name of your container app. Because they live in the same container environment, their name is automatically known within the DNS, within your virtual network, so you can connect that way, but only HTTP. So this is very simple. I can show you how the scaling works. So I have a third example. Again, my API is now scaled to 3 instances always. So the minimum is 3, the maximum is 3. So basically, I always want 3 replicas of the same application running. And if you hit that endpoint, the load balancing is done for you automatically. So it's just a round robin or a random load balancing there. So every time you hit the endpoint, you will hit one of those 3 replicas. Now, if we again do the same thing, we use the URL, go to the status endpoint. You should see the name of the container changing with every refresh. So the end 8M will change every time I do a request. So it's random, so it should be 33.33% in all cases when you do this an infinite amount of times. So if you want to change that, you just go to scale, change the numbers, and save into a new revision, and Azure Container Apps will automatically create a new revision for you. When that's up, it will switch over from the old revision, and now your application is scaled the way you want. Of course, as I said before, if you change those numbers from 0 to whatever, or from 5 to whatever, the scaling is done automatically for you based on your scaling rules in the bottom. Now for revisions and replicas, if you choose your revision mode and change your revision mode to multiple, you can have multiple revisions running at the same time. So I did that for the 4th example. And in this case, I deployed my container app twice. First with the version alpha, and the second one with the version beta, which is that environment variable. So if you go to containers, you can actually change your revision here. So based on revision, my one revision and my other revision. And if you look at the environment variables, this is alpha, and the other one is beta. So now I have 2 active revisions. For your scale, of course, you can change the scale for each revision independently. And if you go to revisions itself, you can change the traffic split between your revisions. So you can do 50-50, or you can do 5-95 if you really want to test your newer version for only a select amount of people. You put that on 1 or 5% or 10% or whatever you think is appropriate. And then you can increase that number if everything keeps going fine, up until you reach 100, and then you can basically scrap the older revisions. Revisions are not scrapped. If you look at inactive revisions, it will basically keep track of all of your older revisions. So if you really screw up, you can always go back to an older revision and deploy that again as your active revision if that is necessary. Again, when you create this in the portal, I'm showing you in the portal because this is very visual. I think this is very easy to comprehend. But of course, when you're creating enterprise applications, you don't want to do this in the portal. You can do everything that I'm showing you from the Azure CLI or by using ARM templates or Bicep templates to basically deploy automatically. Of course, that is the way you want to do it. But all of this is also available, of course, in the CLI and templates. One thing that I haven't shown you is if you look at the container environment itself. So this one, this is the container environment. It also has a list of all the applications that are running within this the same environment, all the container applications that are running here. But you also have the concept of workload profiles. So when you create your container environment, it will ask you, do you want to use consumption workload or do you want to use custom workloads? And here you basically get the flexibility of maybe not always to go for the consumption-based model. The consumption-based model means you can scale down to 0. It's a serverless offering. You can very easily specify how much CPU and how much memory you need for specific replicas. But you can add multiple custom workload profiles by choosing a size of a virtual machine. So you have very specific machines that you can actually use as nodes, and then we are getting closer to Kubernetes again. Maybe you want your application is business critical, or some components in your application are business critical, so you want them to run always and you want them to run in a very specific way. Then you can add a workload to your profiles, a very specific workload. These are all CPU-based workloads, but you can also have GPU-based workloads if you want. You can add them, you can configure them, so I can select whichever. And you can also define your auto-scaling for your node sizes. So I have this size of node. I want at minimum 3 and at maximum, for example, 5. And this will then be scaled for you in the background based on how many resources your replicas are actually using. So if you add a profile like this, which is the best name here, and you create or deploy a new container app. So if I go here and I do create container app, you basically select your container app environment, and then in a later step, you select on which workload you want to run this. You can, again, choose the consumption, because that's available in your environment, or you can use one of those custom profiles that you created. And some of your applications or container apps can run on one workload. Other of your container apps within the same environment can run on a different kind of workload. So now you have the flexibility for different kinds of application to use different kinds of workloads, basically. If you have a lot of CPU processing power necessary for one specific service, you use a very high CPU-based virtual machine as a node, or workload in this case. If you have something different like memory needs or GPU needs, you can specify that also. Now, container apps are cool. They are flexible. We have a lot of the functionality abstracted away from us, and we can very easily make that work, which is something that I think is the case. And of course, we have the added benefits of all the open source components that are installed there. So I also want to show you some of these other things. This is not an Aspire talk, but I want to show you .NET Aspire as part of Azure Container Apps. So a .NET Aspire, specifically for .NET of course, is a distributed application orchestrator. So if you want to very easily create distributed applications and you want to deploy them to the cloud, but you also want to run them locally in a very easy way, .NET Aspire can really help you. It basically allows you to create an application composition and does automatic service discovery. So you don't need to configure where all of your application components live. It will do that a little bit for you automatically. And it also supports components to talk to external services. So if you want to talk to external services like a cache or a data store, you can actually use components for that to make your life a little bit easier. And again, to focus on development and not so much on infrastructure or configuration for that infrastructure. There is tooling support for Visual Studio and the Azure CLI. So let me just show you what that looks like. So this is the default Aspire demo, because I don't want to go too deep into Aspire, but basically I've created the same kind of thing. There's an API service and there's a web application. So the API service has an endpoint that we can call to get weather data, which is the default template for Visual Studio. And we have a Blazor web application that gets that weather data from its front end using that API. Now, if you use Aspire, you can create a new Aspire project, and it will do all of this automatically for you. But you can also convert your current applications into the Aspire model by adding Aspire to existing solutions, which also works. And what it does, it creates a separate project called the app host. And the app host is actually the project that gets run and ties all of your services together, does the service discovery for you. And it will do that just by writing some C#. So you don't need to know about YAML or any other weird configuration languages. You just write a little bit of C# that basically tells you that you have a distributed application. You're going to build a distributed application. And you're going to add to that distributed application builder, for example, a Redis cache. This is an external service. I didn't create the cache myself. I'm going to use the external Redis cache. So I'm going to add this to my distributed application. And the name for this cache is called cache, whatever. Then I have a project within my current solution. And this uses a little bit of code generation. So basically, when you compile your solution, it generates a little bit of code using source generators so that you can easily configure which projects need to tie together. So I have an API service project, which has this project name, Aspire Example API Service, which is this one, the top one. And I'm going to add that as a project. Then I'm also adding the web front-end project, which is this Blazor web application here. Also adding it, but I'm adding it with some external HTTP endpoints, which means it's going to call external HTTP endpoints with a reference to our Redis cache and with a reference to our API service. And now we just told it we have dependencies. Our web application has a dependency for the Redis cache. It has a dependency for our API service. And the service discovery will be done automatically. I don't need to worry about domain names or IP or port names. It will all do that for me automatically. Now, if you run this app host application, it will run all of the components separately. And as an added bonus, you get a little dashboard with that. So I think this is very powerful for local development. So if you're working in a team or multiple teams and you're working on a distributed application and you're using Aspire, you basically make it very easy for your new developers, for example, to get their environment up and running very quickly. Because you have, for example, one solution. Some of the projects are within that solution and you can just run them locally. Other projects are external dependencies like the Redis cache or even external applications within your same company, but you can also pull them in by using their container images. So in this case, the cache is a container image that's being pulled automatically by Aspire, so it will pull it from the registry, and it will run that using, in my case, Docker Desktop. Then we have the API service and the web front end, which are both locally run projects. You can see all of the endpoints that are configured for you. You can click those links to visit whatever service is behind there. This is the Blazor application. And if I click weather, this weather data will be fetched from the API. Now, if I keep refreshing this, you can see it changes. Now it stays the same for 5 seconds or 10 seconds, whatever, and then it changes again. So this is using that Redis cache. Now, when doing this, you can use the dashboard for console output for each of your projects. So like, what is my API service console log? What is my cache's console log? You also have traces, so you can see whenever I refreshed the page, the weather page, you can see what actually happens. And if I scroll back a little bit, here, for example, you have a trace that actually shows you that I'm doing a get on the weather page in my Blazor application. Then it goes to the cache, the Redis cache. It doesn't have the information in the cache yet, so then it does a get to the API service, and it stores the result from that API service in the Redis cache. So now you can see nicely what component is talking to what component, when, and how much time it takes. Very cool. Now, of course, my perspective on this is that Aspire is great for local development. So if you want to very quickly load up all of the components that you need in order to test something, this is very powerful. But you can also deploy this to Azure Container Apps if you want, and it's actually quite easy. You can do something like, let's see. If I go to my example 5, which is my Aspire example, again, it's on GitHub. You can use the new AZD, which is the Azure Developer CLI. So it's not the Azure CLI, it's the Azure Developer CLI. And this can actually help you to work with Aspire and deploy your Aspire applications to the cloud. So I can do something like AZD init, and this will initialize your current project or solution as a deployable Aspire application. So it will ask me, do you want to select a template of different kinds of things that I can deploy, or do you want to automatically look at your code and specify that way what you are using? So I'm going to say use the code in the current directory, and it's going to scan that code, and it's smart enough to see that this is going to be an Aspire application. Smart enough, I said. It's a little slow. Let's give it some more time. There we go. So it says detected services.NET Aspire, and then it says it will generate the files necessary to host your application on Azure. So I can confirm and continue to initialize my app. It also asks for an environment name. So if I want to deploy to Azure, I'm going to specify an environment name. So it will basically create new resources based on this environment name. So I don't know what I already have on my Azure. So let's take something like that. And now it generates some files that basically describe I want to deploy an Azure, a .NET Aspire application to Azure. It creates some metadata. And then it tells me you can do something like AZD up to basically create all of those resources. So again, it goes to analyze, and what actually happens is it will create all of the bicep templates, bicep scripts to do the actual deployment. So that's also easy for you as a developer. You can actually use those biceps, and you can change those biceps to help you to basically deploy your application to Azure, but it can also do that automatically for you. So in my case, it asks me which of my Azure subscriptions do you want to use. I'm going to pick the first one. It asks me what region do I want to deploy to, so West Europe, for example. And then it starts creating those biceps. By default, it only does that in memory. So it creates those biceps in memory, it will use them, and it will basically discard them afterwards. But you have some optional parameters you can use to basically store those bicep templates as part of your project, and then you can reuse and change them afterwards if that is necessary. Now it gives me an error. I'm not going to look into that, but I already deployed it beforehand. So let's see. If I go to resource groups, this one is the one that I already prepared beforehand. So it created for me a container app environment. It created my API service and my Redis cache and my web frontend, then some log analytics, a managed identity, and a container registry. So all of these are the components you basically need to create your container images, put your container images on the registry, create those Azure Container Apps. They will pull those images from that registry, they will spin them up, and all of the configuration with that is done by .NET Aspire, again, service discovery. And the cool thing about this is that you can also use the .NET Aspire dashboard live on Azure. So this one is now hosted on Azure. It automatically sees, again, all of your resources. Now they are not project resources, but they are all containers, they are container apps. And all of the information in the structured and console layouts and the traces and the metrics, they are all fetched from your log analytics workspace. So the information is stored in the log analytics workspace, and the dashboard basically shows them to you right here. So this is what Aspire can help you with. And again, very easy to deploy that to Azure Container Apps. Would I do this for demos? Yes. For little things that I'm playing around with? Yes. For enterprise applications? Probably not. I will probably still write my own bicep scripts and use pipelines to do the deployment for me. But again, it's a nice way to start. It's a nice way to learn about it. It's a nice way to deploy your smaller applications. Actually, I'm not going to talk more about Aspire. There's a talk tomorrow on Aspire, specifically on Aspire and Azure Container Apps. So if you want more information about that, I would suggest you to look at that one. The final thing I want to talk about is Dapper. I told you that Azure Container Apps is built on top of a couple of open source components, and Dapper is one of them. So what is Dapper? Dapper is the distributed application runtime, which actually means you can use that to more easily create microservices or distributed applications. Again, and you can use any language or framework. Now, again, what does that mean? Basically, when you create your application components or your microservices, they need to communicate with each other, and there's a lot of things that can go wrong. It's easy when you have .NET services talking to other .NET services, but maybe within your company or with your external dependencies that you have, you need to talk to other platforms. You need to talk from a .NET application to a Java application, or something you don't even know. That will make it a little bit harder. And what Dapper tries to do is it tries to abstract away all of that. You basically focus on your application, and when you need to communicate with an external service or with another service within your microservices application, you use Dapper, and Dapper will do that for you. The benefit of this is, again, you also don't have to worry about things like resiliency, for example. Resiliency, when something goes wrong in your network communication, what do? Are you going to retry? Are you going to drop it? What are you going to do? Again, Dapper can solve these issues for you by just doing a little bit of configuration. I stated it before, you focus on your application code, on your logic, and Dapper will basically focus on how to tie everything together, how to do inter-service communication and communication with external dependencies and services. Just like Aspire, Dapper also has the concept of components, so you can use readily available components to talk to well-known services. If you want to talk to a Redis cache, there's a component for that in Dapper, and you can use that to talk to a Redis cache. The architecture for Dapper is very cool. When you use it in Azure Container Apps, for example, each container app, as I showed you, contains your container that is running. But for Dapper, it will actually run a second container next to your container. So you now have two containers running in one single container app, which is something you can also do yourself. But Dapper does this also. And in Dapper, we call this a sidecar container. Now, when you want to do something with the rest of your application, you want to call into another service. For example, service on the left-hand side wants to talk to the service on the right-hand side. You're not going to directly talk to this service, but you're going to talk to the Dapper sidecar. And then the Dapper sidecar is going to talk to the Dapper sidecar from the other service, and then that one is going to talk to the service itself. So of course, you have a little bit of a detour there. But the added benefit is you don't need to worry about the communication itself. Dapper will do that for you. You don't need to worry about resiliency. Dapper will do that for you. Dapper will do the retries for you based on your configuration. And inside of your code, you're just doing an HTTP request. And when something goes wrong, it's out of your responsibility. So Dapper will fix that for you. And again, you can also call to an external service using a component within Dapper to be able to do that. Now you can also see the arrow between the Dapper sidecar and your own services. Basically, you have two options to do communication between those two. You can directly call into the Dapper HTTP endpoints by just using your HTTP clients. That is one option. But Dapper also has SDKs that they provide as packages for whatever platform you're working on. So for .NET specifically, there's a NuGet package that contains all the functionality for Dapper. So you can use that NuGet package to talk to your sidecar and then talk to another service afterwards. So the Dapper components that you can use to talk to your own services or external services are basically split up in different kinds of components. We have the input and output bindings, basically to specify how your incoming and outgoing communication is going to be handled. You have something called state stores for storing data, for storing cache, for retrieving data, retrieving cache. There's also secret stores for configuration secrets. For example, if you want to talk to Azure Key Vault, you can do that from Dapper using a secrets store component. There's configuration stores for other kinds of configuration. There's PubSub if you want to do queues or publish subscribe kind of scenarios. And there's middlewares if you want to tweak whatever is going on within the pipeline for your communication with Dapper. So let me show you how this works. If I can find it. So I've created a small sample Dapper application. Hopefully this is the correct one. Nope. It's this one. So things change a little bit, of course, because you're not talking between your services directly, so you're going to use Dapper. So in my case, my worker is actually going to add the package Dapper ASP.NET Core in order to communicate with the Dapper sidecar. It's going to be the same for the API. Now, again, my API is going to use the Redis cache. But I'm not using the Redis SDK directly. I'm using the Dapper SDK. And in the Dapper SDK, you basically add a Dapper client to your dependency injection container. And the Dapper client will do everything for you. So the Dapper client is the one that talks to the Dapper sidecar. And if you added this to your dependency injection container, you can basically inject the Dapper client wherever you want. And then you can use the Dapper client to do all kinds of things based on all of those different kinds of components that you have. So in this case, I can, for example, do get state async. And get state async, in this case, uses something that is named Redis. So you basically specify which service you are talking to, the name of that service, which is Redis, and then you use the key to get the Redis key value pair back. And then this goes to the sidecar talks to the external Redis service, it tries to fetch that for you, maybe it will retry if something fails, and then when it gets a result, it will return that to you. In this case, when we have a cached message, we return this, otherwise we generate the message, and we save that new message as that cached message. So next time we call this endpoint, it will get it from the cache instead of instead of generating it. I'm sorry. Now, again, the cool thing about this, I don't need to worry about configuration in my code. There is no connection string to a Redis cache. There is nothing. The only thing that is here is my Dapper client. Of course, we create a hard-coded, like hard-coupled dependency on Dapper in this way, but you can also abstract that out yourself if you want. You can create, you can put your Dapper client like somewhere to the side and then use dependency injection to make an abstraction on top of that. But in this case, the only thing you have here is your Dapper client, and all of the rest for configuration-wise is nothing for you to worry about. It's going to be the same thing for the worker service. So if you remember, the worker service is going to call my API, but I'm not directly calling my API. Again, I'm using the Dapper client. in this worker service also. So I'm adding the Dapper client to my dependency injection container, and within my worker, I'm injecting the Dapper client, and I'm using the Dapper client to invoke an HTTP method. So now I'm not getting a state, I'm invoking a method, which is a different kind of component in Dapper. And I'm invoking an HTTP GET method to a component with this name, and this is the name of my endpoint, or basically something you put behind of your root endpoint, so /status. And this is what it returns to me. In this case, it's just a result. It can also, of course, be a JSON deserialized object or DTO if you want this. Now, this is your Dapper. Of course, when you run this locally, you need to configure Dapper locally. So you have to add some folders to your project and have some configuration files there. But if you deploy this to Container Apps, that is something you do within Container Apps itself. So if I go to my example for Dapper, for example, let's see, my API. You have a small menu item on the left-hand side called Dapper, and you can enable or disable. So by default, it's disabled. I told you Dapper is pre-installed with Container Apps. You can use it, but you need to enable it before you can use it. And when you enable it, you specify your app ID, which in my case is example 6 API. So this is that ID that I'm using in code. So in code, when I'm doing the invoke method async, I tell it, this is the ID of the app that you need to call to. And this is the same ID here. So I specify on this container app, which is my API, that this is the Dapper app ID. And this is the port that my API is listening on. So this is basically information for that Dapper sidecar to know within that container app. So the sidecar knows that the container that lives next to it is the example 6 API, and that it needs to talk to that API using port 8080. The protocol you can change between HTTP and gRPC, which is basically the inter-sidecar communication. So that it can go over HTTP or gRPC, which you can choose if necessary. Some other configuration values if you want to see the Dapper logging within your API logging. So if you look at the log stream, for example, and you enable this, all the Dapper logging information will also be there if you want to learn something from that, for example. And then in the bottom, you have a list of all the Dapper components that you are using if you want to talk to external services, for example. In this case, the API itself does not use a cache. I didn't show you, but I'm not using the cache for the API. I'm using actually the cache for the Blazor application. I'm sorry, this is the wrong example. Whatever. But if you go to your container app environment, because it says in order for your app to use a specific Dapper component, it must be added to your container app environment. So you specify on top of your environment which Dapper components you want to use and where you want to apply those components, and then they become available for your Azure Container Apps. So if I look at Dapper components, I have added Redis. And you can add whatever components. So you can use generic components for Dapper itself, or you can integrate with other Azure services by using an Azure component, which is still in preview. But if I click this and have some patience again, I can specify the component name. So this one is Redis, but I can do whatever name. I specify a building block. Is it a binding, a configuration, pub sub, secret store? So those are those different kinds of Dapper components. So for example, Redis will be a state store. And then it will list for you what kind of state stores are available within the Azure ecosystem. So I can do cache for Redis. And then it will load all of your Redis cache services within your subscription, and then you can choose it from here. For example. And if you add this, now you have a component that is configured to talk to an external service, and you can use that component within your application, within your Dapper application. So if I open this one to show you the details, you can see it basically adds metadata to make that work. The Redis host, this is the endpoint to talk to Redis. The DB is the one with index 0, the password, and if you want to enable TLS, so this will be added for you automatically. But you can also add other metadata that is supported. So for example, I added time to live in seconds, 5 seconds, which means if I want to add something to the cache, the time to live for that value is 5 seconds, and after 5 seconds, it disappears from the cache. So your configuration is happening here and not in your code. If I go back to my worker service then, and I also enable Dapper in my worker service, it should actually show me the Dapper component here in the bottom, but it doesn't. So that's going to be for another time then. Normally, when you add components to a specific service that you're using, you basically add it as a scope. So I say I'm going to use Redis cache from this application. You add a scope to your component, and that component will only be available for the container apps within the same scope. So it will show up here. I don't really know why it doesn't work right now. I probably made a mistake on my end. So yeah, this is, again, a very quick introduction in what Dapper can do for you within Azure Container Apps. It's all integrated. You configure it there, again, or in the portal, or using whatever infrastructure as code that you're used to. But again, you don't need to worry about it from your code. It just works if you configure it correctly, obviously. Now, there's one more thing that I want to show you. It works in Dapper, but it also works in container apps, which is resiliency. So I have created an application, this one, with a status endpoint that basically generates a random number, 1 or 0. And when it's 0, it throws a random exception. So if I hit this endpoint, sometimes it's going to give me an HTTP 500, sometimes it's going to give me a result. So that's another very reliable service. Within Azure Container Apps, you now also have the opportunity to enable resiliency. So if you scroll down, you can find resiliency preview. And you can actually enable resiliency for different kinds of topics. For example, HTTP retries. And I can, for example, react to 500 kinds of errors. So everything in the 500 range, I will react to. And I basically will do 1,000 retries, for example, with an initial delay of 100, and it will do a progressive backoff until a maximum of 2 seconds. This is just random numbers that I've chosen, but of course you need to think very carefully on how you want to configure this. Maybe you want to retry quicker or slower, depending on what kind of resiliency you want to build. So if I disable this, and I apply, and I open this URL, and the status endpoint, now it doesn't work. It gives me an HTTP 500. And I just keep on refreshing. Sometimes it works. Sometimes it doesn't. So you can see it's random. Now if I go back to resiliency, I enable HTTP retries, 100, whatever. Let's say initial 5 seconds, just to make it very clear. And I save this for the 500 range. And I try this again. Now you can see the page is loading, and it's probably going to take 5 seconds, or if things go wrong, longer, because it's now retrying in the background automatically based on the resiliency settings you have there. So now it went immediately. Again, now it takes, it was pretty immediate. Again. Now it's taking 5 seconds again. So now it's retrying in the background, waiting 5 seconds, and then retrying and succeeding. So again, also something you don't have to worry about in code. You can configure using Azure Container Apps, and all of your services that are calling this service, they benefit from that, because they don't have HTTP errors, because basically they are retried automatically. Of course, when retrying helps, in some cases retrying will not help. It will always throw an exception, so you also need to worry about that, of course. But that's it. So I've shown you Azure Container Apps very quickly, I've showed you what you could do with that. I've shown you Aspire, and I've shown you Dapper. And with that, I'm at the end of my presentation. So again, everything is on my GitHub. If there's any questions, I would love to hear them. And otherwise, have fun with the rest of NDC Oslo.